as you've been looking at your planisphere and tracking a constellation, how it looks different through the months, it really seems like we're focusing a lot on the view from Earth. And we need to begin sort of changing that around and looking at instead what the view from Earth shows us about how Earth moves in the universe. And to do that, we're going back in time. We're going to talk about some different ancient civilizations that sound familiar. Hopefully they sound familiar, because these people spent a lot of time observing the skies and using these patterns that we don't notice as much nowadays because, quite frankly, we spend way too much time inside. So there are a few videos that I just want to talk you through here and get you to begin thinking about what this apparent movement of constellations really is telling us.
Thanks, Jen. Perhaps the greatest ancient astronomers were the Mayans, who lived right here where I'm standing. The Mayans inhabited the Yucatan Peninsula in Mexico and Guatemala. These people made...
Sound familiar? The Mayans on the Yucatan Peninsula in Guatemala. Now we're going to look at them from a different viewpoint.
Astronomical and seasonal observations which rivaled anything seen in Europe during the Roman Empire or the Dark Ages. These amazing people mapped the heavens, they evolved the only true writing system native to the Americas, and they were masters of mathematics. They invented calendars that are still accurate today, and without metal tools, beasts of burden, or even the wheel, they were able to construct vast cities with an amazing degree of architectural perfection and variety. The largest structure at this site is El Castillo, the castle. That these temple builders were mathematically precise in their architectural designs is borne out by the natural phenomena which occur during the fall and spring equinoxes.
So here is his evidence that these Mayans paid attention to the cycles in the sky. Now the fall and spring equinox, fall happens one day in the year and spring happens one day in the year, the equinoxes. And so one day in the fall and one day in the spring, here's what happens on this huge structure.
In the spring, as the sun rises, the shadow cast on the steps appear to form the body of a serpent, which...
So in case you didn't see it the first time through, I'll rewind it a bit. One day a year, it looks like a serpent crawls down.
Which occur during the fall and spring equinoxes. In the spring,
so watch this side
rises,
here. Watch the light.
The shadow cast on the steps appear to form the body of a serpent, which slithers down the stairs.
And it was built with a serpent head at the bottom. Now, does that shadow happen every day? No, just on the first day of spring. And so they really had to observe a lot to know how the Earth's movement and where the sun was going to strike, how those things happened in patterns in order to build this whole honkin' pyramid to make it look like a snake crawled down it on the first day of spring.
Here at Chichen Itza, there is a structure unlike anything else ever created by the ancient Mayans. It's called El Caracol, and it actually looks like a modern observatory. Its design didn't function the same way as our modern observatories. Instead, its walls contain many windows. Inside the dome, stones could be removed, enabling the Mayan astronomers to observe different parts of the sky.
Isn't that cool? So they could focus just on one part of the sky. Now, we're going to a different video, and this one is going to bring in the idea of seasons, and we are going to start it a little ways through and watch all the way to the end because there is some geometry that you are supposed to learn in 4th grade, but that you missed. So this is a good way to pick up some of that geometry. But first, we have to get it to the right spot. We're going to start it approximately 3 minutes and 11 seconds in. 3:09 is close enough. Here we go.
Approximately 5,000 years ago, they devised a way to place stones in certain positions to align for lunar and solar events. Events like seasons were noted and found to recur regularly with certain positions of the sun and stars.
The Earth spins on its axis once every day and gives us the familiar experience of daytime and nighttime. For thousands of years, humans have used this cosmic cycle to regulate their workday, their meals, and their sleep. The Earth orbits the Sun once every year, and from this we get the familiar 365-day cycle. Earth's orbit around the Sun is an ellipse. Basically, that means an oval, with the Sun offset from the center of the ellipse. Does this mean that we have summer when the Earth is closest to the Sun and winter when the Earth is farthest from the Sun? The surprising fact is that the distance from the Earth to the Sun has absolutely nothing to do with the changing seasons. Our northern hemisphere is closest to the Sun in January and farthest from the Sun in July. So what is causing the change in temperature?
This should sound very familiar. You should be able to say right now what causes the change in temperature due to the different seasons. Here's what the video says.
Earth's axis is tilted by 23.5 degrees from a line perpendicular to Earth's orbit. What does this mean? To understand this tilt, we have to use a bit of basic geometry. An angle has two sides and a vertex. The sides are rays that share a common endpoint called the vertex. The angle formed by two rays can be named in a variety of ways.
And this part is where it begins the geometry that you should have learned in 4th grade. So you might want to rewind this a few times to get a bit more familiar with it. I'm only going to have it show you once.
For example, the angle formed by ray AB and ray AC can be named angle BAC, angle CAB, or angle A for short. Notice that A must be the middle letter in both three-letter names, because it's the vertex. You can measure angles using a protractor. The unit of measure is degrees. Angles can be classified by their measures as acute, right, obtuse, and straight. If the Earth rotated on its axis...
I'm going to go back to that for a minute. All 4th graders in the United States are supposed to know about acute and right and obtuse and straight angles. You're in 5th grade. If you don't know it, watch it a couple of more times to remind yourself.
In both three-letter names, because it's the vertex. You can measure angles using a protractor. The unit of measure is degrees. Angles can be classified by their measures as acute, right, obtuse, and straight. If the Earth rotated on its axis perpendicular to, or at a right angle to the orbit, there would be no changes in temperature. The Earth rotates at an angle 23.5 degrees from this perpendicular line. It's a very small tilt, but enough to affect the sun's rays hitting the Earth. This is a great time to pause the program and think about the following questions. Why is the area near Earth's equator hotter than the areas near the poles? If the tilt of Earth's axis measured 33 degrees rather than 23.5, how might seasonal changes and temperature ranges differ?
No, we are not going to pause it.
It's now time to pause the program.
We are just going to keep
The
watching.
tilt of the Earth's axis gives us our seasons, and because of the extremes in heat and cold, it's very important to keep track of the changing seasons if you're growing food. This seasonal cycle is important to ancient and even modern people. In some parts of the world, like the arid climates of the southwest states of the USA, the growing season was so short that people could not waste much time getting the seeds in the ground at the start of spring. But how do we predict when the growing season will begin in the spring? For that matter, how can we tell when the other seasons begin and end? It turns out that just by keeping track of how high up the sun gets over the horizon at noon, you can determine the start of the seasons exactly. Almost all ancient people that relied on planting times discovered this little relationship. The start of the four seasons, summer, fall, winter, and spring, are noted by what astronomers call the summer solstice, the fall equinox, the winter solstice, and the spring equinox. At the start of summer, around June 21st in the northern hemisphere, the sun is at its highest point above the horizon at noon. As the sun begins its movement back away from its maximum height, the number of daylight hours has declined to an equal number of daylight and nighttime hours. This is the fall equinox near September 21st. A few months later, the path of the sun arrives at its lowest point at noon. The sun spends very little time above the horizon of the northern hemisphere, and the night is much longer than day. Welcome to the winter solstice, or start of winter, around December 21st.
There's just a few seconds left and we don't need to watch that. The last video for today. We will start this about 40 seconds in. This is another group of ancient people that we have talked about. They are those who lived in the desert southwest.
In Hovenweep National Park in southern Utah. I'm a Cherokee Navajo. I live not far from here, and I'm an educator on the Navajo Nation. A cultural astronomer means you deal with the astronomy of your own culture, and we put things within the context of a native worldview. Right behind me on the boulder, you can see an indication of a solar phenomena. On the boulder, there's two images. One's a concentric circle, one's a spiral. As the sun begins to rise, shafts of light coming from each direction, and as the sun continues to rise, the lights meet in the center. This only happens once a year. This phenomenon occurs on the longest day of the year and is a very appropriate way to mark time. This can be a very harsh environment to live in. It can be hot, it can be cold, and it can be very dry. In order to survive, people had to live in accordance with the natural environment, and that meant the natural cosmic environment, the sun, the moon, and the stars. It was very important to track the path of the sun and the moon and certain constellations, and to do that, people used natural markers like petroglyphs and sun and moon alignments. Remember, there was no watches, there was no timekeepers, there was no calendars.
My name is David Begay. I am a cultural astronomer. I've been living out here for many years. Clan is Maidishkizhni. This clan is a descendant from the Jemez Pueblo people. And here is one of the structures at Hovenweep National Monument. This structure had many purposes, one of which was an observatory. The ancient had a profound respect for the movement of the sun and the stars. On the longest day of the year, the sun shines through an opening and the light falls on a marker. What people experience here is really a cultural experience. It's a whole life experience. People felt the movement of the sun. People felt the movement of the moon. It was a daily experience. Among the Navajo people, for the sun, when it reaches summer solstice, it's a total life experience. People used to talk about the solstice being a 4-day phenomenon. People used to say, the sun spent 4 days before it starts moving back the other way. So it's really something that was experienced, it was talked about, it was a part of the culture that's been passed on through the generation. I think people talk about these movements in terms of days. I'm not sure if you can really call it special math. I don't think tracking the sun down to the second was important at that time.
These buildings and boulders are remnants of ancient civilizations, much like the ruins in Rome, the ruins in Greece. And today, they're still very relevant to us out here in the Southwest. We still see the same sky, and we're in awe of the technology that was employed to build these buildings and capture these solar and lunar alignments.
And it is really pretty darn awesome how they were able to do that without what we would consider math. That includes calculators. So the idea of tracking a constellation or watching what happens in the sky, this is a very ancient way of looking at things, but it really does make sense.